Let me introduce myself. My name is Jerry Zion. I work for Fluke Biomedical, which is becoming Fluke Health Solutions. And the reason that we're doing that is because, as you can see, I'm not wearing the Fluke Biomedical logo shirt today. I'm wearing a tri-brand shirt. So that's Fluke Biomedical RaySafe and Landauer now. So who's heard of Landauer before? Oh, that's good. So 3 out of the most of you anyway. So Landauer makes legal dosimetry badges to monitor people who are all around radiation emitting imaging. So that can be both treatment, like for cancer therapy and stuff with linear accelerators, but it's mostly also just regular X-ray systems. So that's what they do. And they also are handling our aftermarket hospital real-time dose management. So aside from the legal dosimetry, it gives somebody who's working in the cardiology suite all day, every day, an opportunity to manage the dose they're receiving in real time. That's a different subject for a different day, but at least you know what they do. So we are now all Fluke Biomedical until we become Fluke Health Solutions. But you can see why Health Solutions, because the personal dosimetry is definitely really right there on the person, helping them stay safe themselves. The rest of the story is part of what we're going to talk about today in 2 sessions, this one and the one right after, about test instrument calibration. Our topic today, I'm the global training manager. So my job is to train everybody, our associates, our sales channels and reps, and all of you to help you be better with our test instruments from the very beginning. And as far as I'm concerned, I don't want any of you to scratch your head and say, I don't get it when it comes to the use of our test equipment. And I want you to really have a deeper understanding of the medical device categories that we're testing with it, and understand what it is that you want to know more about when you go to service schools from the medical device manufacturers, or what you want to know more about from us, right? So the topic today is 10 best practices for ventilator testing, but I'm not here to just stand in front of a PowerPoint presentation and say what we think these 10 best practices are. How many of you are doing ventilator and anesthesia system testing right now? Okay. How many of you are testing the host of other medical devices that exert a gas pressure or produce a gas flow? How many of you test aspirators? Okay. How many of you test endoscopic insufflators? Okay. How many of you test flow meters that plug into the head wall or the ceiling? All right, how many of you test the argon gas output of an electrosurgery unit? All right, so you are testing medical devices that exert gas pressure and produce gas flow. You deserve to have a test instrument that will let you do all of that. Okay, good. Yep. Thank you. So right now, we're just going to focus on ventilators because they definitely are for the life support, right? And they're top of mind for us. And a little later in the coming year, we'll begin to talk about a little bit more about anesthesia system testing. Today, we're just going to keep it to ventilators, okay, if that's fair. So let's take a look at where we are. So we're talking about best practices. What in your mind constitutes a best practice? If we say best practices, what are the kinds of things you would expect to find in that list? Safety testing. What else? And regulatory requirements, and how do they come to you? How do they come down to you?
Well, a lot of times it's a service manual, so doing what the manufacturer requires.
Yes.
So that we can prove that to the regulators.
Excellent. So indeed, that is how the regulation comes down and touches all of us that are working in hospitals. So I should ask that question. How many are working in hospitals? Right? And I don't see any, who's working for a medical device manufacturer? Okay, and who's working for some third-party organization that touches on any of this? Okay, good. So we have all of our constituency in the room, someone from each area, which is really good. So please speak and help us understand things that are concerning your area as we go through this. So yes, so the international standards in particular for any medical device manufacturer that is selling their products out in the world, and that includes companies that are offshore from here that are trying to sell their product into the United States. They have to follow regulations and so forth because they can't bring their product in without a clearance to market from the US FDA. And the FDA will hold them accountable to the international standard. Okay, so the international standards indeed find their way through design validation testing and the test procedure used on the final assembly on the assembly line or the assembly cell in those manufacturers, and finally into the service procedure that you'll generally find in the service manual, brand and model specific. So indeed, that's how they come to us. And why CMS, who knows what CMS is? Okay, good, all of you, excellent. CMS has mandated that we do that. And if they audit us or any of their appendages audit us, that's what they expect to find, that we're doing that. Okay, so yes, and it indeed is a best practice. That's what everybody all over the world is doing, partly because we're helping engage with many, many other voices to help everybody understand that is the best practice worldwide. And so that's good. So we have a clear best practice there. Excellent. What other kinds of things do you expect to find as a best practice?
Least cost.
Least cost?
Let me rephrase that. Most effective cost.
Most effective cost. So how would we gauge effectiveness?
Repeatable results.
Repeatable results. Yeah, that's good. Anything else?
Probably the best. Again, best for the dollars is
Best for the
how
dollars.
do we meet our requirements
At
the least cost while maintaining quality and safety.
Mm-hmm. Quality and safety. Talk to me a little bit more about the safety aspect.
Well, I want to make sure that my patients get the best care possible.
Yes, exactly. And that's why we have our jobs. That's exactly why we have our jobs. How many of you know who your risk manager is in your hospital? Oh, that's very heartwarming for me. Good job. Good job. Believe me, when I entered biomed in the 70s, when we were just really starting this career field, we didn't know who the risk manager was. I didn't know until the second hospital I worked at, and he came down knocking on the biomed department door and said, "We have a problem." And I said, "What?" And he said, "We have ESU burn. We have to investigate." And I said, "Okay, what do you want me to do? I mean, we tested it. I'll show you the records." Okay. So knowing who that is matters, because that's one of the ways that we help reduce injury to the patient. And another way, and another possible best practice, you tell me, is when a caregiver, a clinician, has a problem operating a medical device, what do you do?
Make sure the device works, and make sure they're trained properly.
Make sure they're trained properly. Yes, sir.
Create a work order and start your documentation.
Yes, create a work order immediately and start documentation. And it's because it's possible that what they're running into is a real problem with the medical device, either its design or a process by which it was created or even repaired. So we have a responsibility to make sure we're reporting those, and the best way to do it is in the standard way we do work orders and execute work orders all the way through, from preventive maintenance all the way through to the end result and retest. So that sounds like a best practice to me. Would you agree? Okay, well, let's take a look at some of them. How many of you had any gas physics in your education? 1, 2, 3, 4. Again, you're warming my heart. Thank you. I'll tell you why. Because I learned very quickly that without understanding the gas laws, figuring out what's going on with the medical gas flow device, especially ventilators, is not going to be easy. And I took more time to go through things. You got to know at least a few basics. Okay, we're talking about standard gas laws, which many of you will recognize. We have one of the formulas up here. How many of you have visited Khan Academy, K-H-A-N, khanacademy.org? Did you particularly look at their chemistry section and find gas physics?
I have not, but I will.
Okay, well, let me give you an easy way to do that. And my job here is to not be commercial for Fluke Biomedical, it's to be educational. In our Knowledge Center, if you go to a video library and you go to ventilator and gas testing, you will find links to Khan Academy, to the particular section, they put it in chemistry, for the standard gas laws. And there's about 6 or 7 screencasts where Sal, who is the founder of Khan Academy, does a wonderful job, a very easy to understand job of helping us understand the gas laws and how they're important, how they're impactful on what we're going to do. So if you have new people that are starting out that you're trying to groom into this kind of a little bit of a special area of medical device testing, you might want to start them out there. I use Khan Academy a lot, for a lot of things. Okay, so the other thing is obtain and understand the requirement for the minimum performance and safety testing from the standards or the ventilator manufacturer service manual. We talked about that already. It's a good place to start from the procedure itself. It's a little more expensive to try and get a hold of the standards. They are copyright protected. So even though we have copies, we can't share them out with you. You have to go get your own. Okay, sorry, that's the law. Can't help that. So the modes of ventilation. So we try to get to, so the modes of ventilation are not as simple as these, are they? They're all called something different. And when you dig down into the design and the design intent, you can find out why they name a mode in a particular way, and that it works indeed a little differently than a similar mode on a different model. All right, so let's just take a patient-assisted mode. We would normally, so I'm going to start with what I know. So I did my biggest work on the Servo 900 anesthesia ventilator as an anesthesia system with Siemens. And in that case, we were talking about a pressure support. So what did pressure support mean? Well, it meant that we were able to control the triggering threshold on a pressure-based trigger to allow the patient to work a little harder or a little less hard. And as soon as they got to that triggering threshold, they got a ventilator-assisted breath. Okay, that's pretty basic. In Siemens' newer ventilators, they actually were experimenting with a way to sense the diaphragm motion to get to learn that the patient was trying to take a breath much, much, much sooner. The problem is that that was a very expensive sensor. It was going down, I think it went down the esophagus, I think, in order to sense the movement of the diaphragm. But what a wonderful, at least, attempt at an innovation. So innovation also in these modes is happening all the time. Who's looked at the new Puritan Bennett 980 ventilator? Okay, so there's some things, some new things about a very old wonderful ventilator company, now owned by Medtronic, interestingly enough. And frankly, there's a few things about the testing that we have a very sensitive measurement sensor in our new ventilator tester that frankly gives us so much more information. We have to rethink how we make sure we're just getting the important clinical changes and not irrelevant measurement data mixed in, so that they get the right measurement and you get the right measurement when you follow their test procedure. So working closely around these innovations and figuring out what to do is also important. It's a best practice for us as a test instrument manufacturer, but you benefit because when you use something that someone like us has figured out how to work with the manufacturer so we get it right every time. So knowing the modes, who's run into a mode that may be not well understood on ventilators that you're testing right now?
I have no idea.
How about pressure support with volume guarantee? You heard that one? Okay.
But there's over 100 modes out there.
Yes. Yes, indeed. Yes, indeed. And there's some things that they don't like us to call ventilators, but they are. A BiPAP respirator is a breath support, but it's used for what? Primarily sleep apnea, right? It's in almost every iteration of sleep apnea devices that hundreds of people, thousands of people are carrying around with them all day, every day. So, I mean, you could ask who's doing the testing on all of those. But in any case, so there's BiPAP, and BiPAP is interesting. Why? Because it produces two different pressures in the same breath in order to provide the kind of support that it's supposed to provide. When you have two different pressures, they create two different flow rates. Again, go back to the standard gas laws and you'll figure it out real quick. So how are you going to count the breath rate then? Okay, so I pose that as an open-ended question. You can go back and look or go dig it up in your manuals and take a look at it. But it's important to be able to figure that out. So in our older test instruments, the way we did it is we set a breath detection threshold. And that threshold could be increased or decreased. The default value was about 2 liters per minute in order so that we could figure out how to count the breaths. And for 99.9% of all of the ventilators at the time, including the BiPAP units, we were able to get the breath rate count correct. That was critical because that's how we figured out the timing for inspiratory time and expiratory time, which you need to get to IE ratio properly. Okay, so all kinds of figuring out how to do things, how to design them in, and then teach people how to use what you put into the test instrument, just like learning what exactly is this mode of ventilation supposed to do. Who's run into a brand new ventilator with some new modes that you didn't understand in the last year? 2 years? 5 years? Okay. Were you able to figure out what that mode was supposed to do without going and asking the manufacturer or somebody? Okay, that's another good place to go too. Here in the United States, we have respiratory care department with respiratory therapists who are usually, I have always found them really easy to work with. And if I didn't understand a mode, I could go and ask. And if they didn't know, we'd go to the pulmonologist who did know. And then if we didn't get the answer there, then we went to the manufacturer. But it's all about understanding what the mode's supposed to do so that when you test it, you really understand what's going on. Okay? And God forbid we should have to troubleshoot. Okay. All right, so while there's pneumatic powered transport ventilators, the majority of ventilators are powered by mains or a battery. Electrical safety testing is required. Now I have to ask the electrical safety question. Again, thinking about best practices, let me pose the confusion factor for a minute, and then I'm going to ask the question. CMS in 2011, as part of their whole big mandate, said that we had to follow the manufacturer's inspection procedure. In fact, that still stands. Okay. What does the manufacturer test procedure from the service manual point you to in terms of what standard, electrical safety standard, you're supposed to test against?
Like on a Draeger, there's a couple different ones. I can't cite the name, but it's like IEC.
IEC, so they're an international standard. Okay, well, let me give you some help with that. There are two different ones. One is focused on the manufacturer and everything could include your incoming inspection. But at that point, you're allowed to use 62353, which is much abbreviated in terms of the tests that have to be done on it, right? So that's one thing. Okay, so we know that. Why would they want the international standards? They sell them all over the whole world, and the whole world is focused on IEC, not on what we have here in the US. What's our official local national standard? Again, think the medical device manufacturer first before you think your hospital. No, not for the manufacturer. So that is a different requirement. That is requires a quality system, among other things, but it doesn't specify anything about which standard for electrical safety. It is the Amy ANSI ES 601. And this has been the local national standard in the United States for many years now. Many meaning fewer than 30, about 15 years. But everybody has always been thinking about the Amy ANSI ES1, which was 1993. Okay, forget that one. It's gone. And most of you in the hospitals are using, we called it out a minute ago, which standard for electrical safety? NFPA 99. And the reason for that is CMS also, by adopting NFPA 99, automatically adopted the electrical safety part of it, which is different from and kind of in between the IEC 60601-1 and the IEC 62353.
So which one did you say we were supposed to be following?
For the hospital, you're probably fine with the NFPA 99.
Right. But what was the other one you mentioned?
Whatever the manufacturer specifies. So in some cases, they will specify IEC 60601-1 because they're worried about their design validation testing and what they're doing in the production final assembly test and in their service depot. Okay. And when they roll it out to their field service organizations, sometimes their quality manager doesn't understand that they could really do with 62353. There's a testing method there that matches up and correlates pretty well with the IEC 601-1. But the confusion for all of you is, okay, CMS, you told me I have to follow the manufacturer procedure, and they say an international something or other, and yet you also adopted NFPA 99 and told me that's what I have to follow, because both Joint Commission and DNV, who's audited by DNV?
We're getting ready to switch over.
Getting ready to switch, okay. Both of them audit to that part of the CMS, all right? I can see the confusion. So I've had some discussion with some of my colleagues that are trying to teach and talk about the same stuff here. So I think in the United States, if you're following NFPA 99 and you have a rationale documented in your quality program, what you're going to do, why you're going to do it. So if you are not part of the people who write that policy, make sure that you have that discussion, or come on back and let's have a discussion about it. That's part of what I do. Okay. And there are others like me that also will help you sort that out. But you need a policy statement. You need to say what you're going to do and why. Because otherwise you're caught between two different CMS mandates. In your hospital, the reimbursement for Medicare and Medicaid patients is dependent that you pass the audit for that. And it's going to be DNV and Joint Commission that are going to audit it. And for Medicaid, your state health department. How many of you know your hospital is audited by the health department? Okay, who's been through an audit? Tell me a little bit about what they were looking for.
Well, for our stuff, they were looking for specific things that have been reported over, like they went through our reports, and they looked for anything that had to do with, where we had to do a root cause analysis. That's
Okay.
really where they focused. And for equipment, there was only one or two things. Most of it was procedural. But when it came to us, you know, it was like, what's your procedure for this? What's your procedure for that? And I had to sit and explain procedures.
Mm-hmm.
And I want to make sure then we had documentation that we were following the procedures that we said we had in place.
Okay. With the state health department, it's not just about reimbursement for the Medicaid patients, by the way. They are the authority who can shut your hospital down. So it's really important that you figure out how to get on the right side and have the right discussion with those folks. Okay, really important. Okay, so safety standards, especially electrical safety, any electromedical device, whether it plugs into the wall or whether it has an internal power supply, usually that means a battery, has to have an electrical safety test. Here's what NFPA 99 says. See if you agree with me. Because there's been a few changes since 2011. NFPA 99 now says you must test and make measurements on incoming inspection of a medical device. And after any repair in which you open the enclosure of the medical device. Those two times. What about if you send a medical device out for testing and it comes back in? What event happens then? Another incoming inspection. Yeah, so it's not just when it's brand new, it's whenever it comes back. So you need to understand that. I want to make sure you clearly understand that. Document the measurements. For every other inspection outside of that, it's a visual inspection of the key things that fail for electrical safety, but no measurement. So it's the plug-in and the prongs. It's, by the way, the wall outlets do wear out. So I know that's not your job. It's usually an electrician for the maintenance department from facilities, but that needs to be tested too. If you're not testing, just make sure maintenance is. It's the power cord itself and all the strain reliefs. And there are particular measurement requirements for continuity testing. You have like 0.1 milliohms acceptance there of resistance from one end to the other, especially on the ground. Right. So that means all your spare. So if we're in an international world, that's all your spare power cords for anything that has a removable power cord. You got to test those too. So NFPA 99 is kind of moot, doesn't really specify on that. It also doesn't specify on who has ventilators that are electrical safety class 2. Let me back up a minute. Who knows what electrical safety class 2 is? All right. Who knows what electrical safety class 1 is? Hallmarks for recognition are it has an accessible ground pin somewhere, usually on the back, and it has a 3-pronged power cord, class 1, electrical safety class 1. Class 2 are those double insulated things that have just 2 prongs. All right. Now here's the problem. Even NFPA 99 says you must do what they're now also calling touch current test, and that is the old enclosure or chassis leakage test. So here's what that test says. And I'm going to draw from the international standards also, because NFPA 99 somehow tends to not be very specific about these things. The touch current test is supposed to be done to a test point near where the patient or who could touch it or a caregiver could touch the device and touch the patient at the same time. That's the definition. And that test point is a conductive, non-grounded test point. So it can't be a ground. It has to be something other than ground. So first of all, you have to move your test lead off of that accessible ground point, if there is one, which there won't be. There's no accessible ground. And that's part of the problem. So there's some tests you can't do, but you can do the touch current test, and here's how. But NFPA 99 doesn't tell you this. You have to look at ES 601 or one of the international standards. Because you must do the test. You must do the test, and you must document it when NFPA says you have to document it. That if you have no accessible ground point and no touch current conductive, non-grounded test point. Why? Because the whole outside of the test, this device is plastic. Then we have to make the measurement. What do you call the electronic component that is a conductor, insulator, conductor? Capacitor. And that is exactly what we're going to use in order to get this measurement. So you take a 10-inch square of aluminum foil, and if it's very thin aluminum foil, double or triple it up, make your 10-inch square, tape it down to the touchable surface of the device. Now, having done that, we have conductors inside the medical device, yes? The outside covering is plastic, that's conductor or insulator? Insulator. And then we have our aluminum foil, which is a conductor. We have formed a capacitor, and that's exactly what happens in real life. When the patient touches the outside of the medical device, they form a pathway to ground, and some of the current is going to flow there. We need to know how much and what happens if. Okay.
Does it have to be? Probably not 10 inch.
The size matters. That's why they specify in the international standard, they specified in centimeters, but we'll use 10-inch. So you need enough conductive surface area in order to get a credible measurement. You will get a measurement. It's going to be low, but you need to just document how much is there. Okay, how much is there? So, yes, sir.
Well, so you're saying document, you're saying actually write down the numbers, which I'm curious how many people do that. We're saying pass. We're not writing down any numbers.
Wait till the next time that there's an incident and the lawyer says, sir, I don't see any numbers in your documentation. Why is that?
If it was less than cut off.
I'm sorry, sir, it doesn't matter. You're fried, my friend, you're fried. And it's critical. When NFPA 99 says make the measurements, it means document them too. Write them down. You have a database? Yes, a CMMS. Needs to show up on your records. Even if they're just PDFs appended to your work assignment, your work order. They need to show up in there.
So,
Sir.
we're having a conversation here. We just want to make sure we're understanding. Not only using safety analyzer, but kind of piece of 10 square of aluminum.
Flip your test lead to the aluminum foil. I'm sorry, I should have finished
We're
that up.
That's what we assumed.
Yes.
We just want to make sure that we were talking the same
Yes,
thing.
exactly. Just take your test lead and flip it onto that aluminum foil. Yes, exactly. And now you've got a measurement, you can document it. It's your pass-fail criteria is already specified in NFPA 99. So you can determine for yourself, or on some test instruments, you select the standard that you're going to use, and some of them will automatically give you the pass-fail criteria and tell you whether it was pass or fail. That's even better. Now you're objective, not subjective. Okay. So The rule that I have grown up with in this career, 40-year career of mine, has been independent, objective evidence of minimum performance and safety to ensure the good use in terms of medical, and that helps keep the patient safe. Okay, so we turn this into an electrical safety lecture. But yes, sir.
I got a quick question. I noticed that newer manufacturers are requesting installation tests
Fewer.
for ventilators.
That's what you said, fewer?
No, more.
More. Okay.
Right. Not just for the heaters or anything.
Okay.
But the installation tests.
Mhm.
So I was breaking out the old Maker, then I noticed that your newer one has.
Yes, we certainly have been building them in for as old a test instrument as I can remember when I was just a user and a customer. And certainly now we've carried that through all the way to today.
My question is, the voltage, what does NFPA require? 500 volts, 1,000 volts? Or
We just got done looking and combing through the NFPA 99 about electrical safety, and I don't think it said anything, at least we didn't catch it. We'll come through it again. But here's the voltages that we're using. It's selectable, you choose. Either 250 volts DC or 500 volts DC. So if the manufacturer doesn't specify the voltage that should be used, take your choice, document what you're going to do, and keep doing it. Okay, keep doing it.
I think it matters where in the hospital you're doing testing or whatever.
Could be a wet location, you pick the higher voltage, right? So, you're just testing the insulation jackets around the conductors to make sure you don't have current induced in an adjacent conductor, and certainly no arc over. Okay, so from NFPA 99, they'd be all over that, no arc over, right? Because it's all about fire protection. It's all about fire protection. Yeah, good. Good engagement. Thank you. Let's keep going. So sometimes you get a medical device that doesn't have a manufacturer's recommended inspection frequency. You don't know how often you should test it, not just for electrical safety now, for the whole thing. So there are ways that you can follow a good procedure. This is not the only one that I'm going to talk to you about here. This one is used by the University of Vermont, whose leader at the time, Dr. Toby Clark, and two of his employees wrote the book that we now have a contract to publish and disseminate, called Medical Equipment QA Programs and Procedures. And so one of the things that they do, every time they get something new in that they've not had before, and then about every 2 years just to see what's changed and how this medical device is treated in our facility. They do this thing called a risk-based determination of inspection frequency. And it kind of works this way. There are criteria here. I know you can't see the color difference, but the clinical function, physical risk, problem avoidance probability, which comes from your database. Incident history, which comes from outside your organization. Best place, a free place, the US FDA website. Okay, it'll tell you whether there have been ever any incidents of injury or death involved in a brand and model of medical device. Just type it in, it'll pop it up. This is a yes or no question. Okay, and then are there manufacturer or regulatory requirements for testing schedules? Yes or no? And here, if there's an IEC standard, the answer's got to be yes. Because the manufacturer will be following that IEC standard, I assure you, right? Especially for things that are going to go through to pass muster with US FDA before they get to us. So the way this works is, in each criteria you have some choices. You get to pick one. So you pick the best one for the medical device that you're looking at right now. So this was done for ventilators, and the clinical function means how invasive is connecting the patient. How invasive to the patient is connecting them to this medical device? That's the question. So in this case, they picked the devices used for life support, ventilator, I get it. Okay, I get it. So that's a 5, because that's the weighting that it has. If we look at physical risk, is how bad is it if the device fails while the patient is connected to it? All right, and in this case, they picked device failure could result in severe injury to or death of the patient or user, 4. I think we'd all agree with that. The problem avoidance probability is, what are you finding when you do the testing? Is there a history in your own database that causes you to feel like you need to either test more frequently or test some things that the manufacturer didn't think about? Now, CMS, for a life support device, any critical device, which includes life support devices, doesn't allow us to change anything. Okay, and that's bad, because the whole concept of preventive maintenance comes to us from the US Navy, which I came on and I learned my preventive maintenance there. Okay, the idea is to reduce the amount of testing to just the point where you're getting results that you have to deal with. And if you're not getting results that you have to deal with, then you either expand the frequency, push it out some, make it longer, or add some things or remove some things that you're testing until you start getting failures. It goes into the calculation of mean time between failure ultimately. And more than that, what if for those high cost repair parts, sub-assemblies and so forth, we didn't have to order them until we need them? What if we could predict about when we would need them? Wouldn't that be great? That is the nirvana of preventive maintenance, to get to predictive maintenance. But you can't do that without a database that takes your test results in and lets you identify the critical measurements so you can do a long-term trend assessment on them and set some trend limits. When you do that, you get to the ability to predict what's going to fail, and then you order in your part, so your affordability and your budget management become better, your efficiency of testing becomes better, everything is better. Okay, more uptime for the device, which is also a hallmark of a best practice of a quality assurance program. The key here is, especially when we have a medical device or a few medical devices that are mission critical. You understand what I mean by mission critical? The hospital cannot do the service to the patient if they don't have that medical device, that very one, because that's the only 1 or 2 or 3 that they have in the inventory. When that device is down, then the patient has to wait. In some cases, the patient has to wait. It's not good for the patient. The patient's going to get sicker, or they may even pass away. Okay. So you can put it on an economic point of view also. Let's take an X-ray test tube, an X-ray tube, for example. An X-ray tube, the glass is the most expensive, pretty much the most expensive part, replaceable part in the X-ray system. If you have to repair or replace a tube, it will take 2 days. You're going to have that X-ray system or X-ray room down 2 days, no throughput. Isn't X-ray one of the big revenue producers in your hospital? Yes. And that's normal. If you're running into any trouble and it's longer, that's worse. So the idea here is to predict, because that tube is also very expensive. So I don't want to have that tube sitting on the shelf for a year. I want to get it in just before I know I'm going to have to replace it. I want to be able to schedule that room down so that it's not hard down just when X-ray department needs it the most. Right? So that's just one example. I wish I had one for ventilators, but I don't. It's not that there aren't probably some great examples, I just don't remember any. So, so here what we have is a total risk score, when we add all these up, of 17. Okay? The criteria says if it's 13 or higher, we need to inspect twice per year, right? Now what we do with that is we compare it to what the manufacturers say for frequency of inspection in their service manual. Most of the time, it'll agree, okay, most of the time. In fact, up until about a year or two ago, I would have said for electrosurgery units, for example, absolutely it would agree every time. That matches up very well until Medtronic, because they know their design so well and they know the safety or the risk of their design and use so well, reduced their ESU inspection frequency to once per year. Okay, and the question is the ESU electrosurgery unit a critical device or not? I'm feeling like it's right on the edge. Could go one way or the other, depending on what the auditor feels like that day. All right, but if I'm going to guess, if I'm going to make the decision as the director or manager of Biomed, I think I'm going to err on the twice per year side, even though the manufacturer said only once. How about an infant incubator? Kind of the same thing. In ventilators, I absolutely want at least twice a year. But keep in mind that there are still many ventilators out there whose frequency of inspection is not based on the calendar. What's it based on? Use hours. Use hours, right. And there are several different levels of maintenance for several different subparts of the system that are based on that use hour. For example, a compressor might be 10 to 20,000 use hours, whereas other parts of the ventilator that are critical and need to have some components replaced are going to be every 2,000 hours or so. All right, so don't get trapped into thinking only of the calendar way of thinking about inspection frequency. So this one's going to be twice per year, and it will agree with most manufacturers. Although if you have a real high use inventory of ventilators in your hospital, you might get to a use hour much quicker than that. You might end up with 4 inspections per year, depending on how things are going. So that's those, and the use and abuse, which goes here in the problem avoidance criteria, are why the University of Vermont looks at this about every 2 years throughout their full inventory. They just spend a little time running down through, it doesn't take very long, and just comparing that back to the manufacturer and figuring that out.
Sure, got a question.
Sir.
So is this equivalent to the work that needs to be done in order to establish an AEM program?
It could be. So tell me if I'm not talking about the same thing. But one of the other things that University of Vermont does is they have a criteria for figuring out whether a medical device is even going to be included in the routine inspection list and be managed in the work order system. Because there are some things, let's just go back for a minute, that are 8 or less on the total risk score. These are things like exam lights, exam tables, hospital beds even. Except hospital beds, the guardrail problem continues to plague us. Every year there are pediatric patients and others, or even adults who are injured by those bed rails collapsing just when they shouldn't. The device manufacturers are really looking into that. It's a serious problem they don't want to have happen, but it still does. So aside from that, there's not usually much risk to the hospital bed. But it's those kinds of things. And you could even, we say less than annual. Here's where we might take another NFPA 99 trick, okay, and say, well, in our policy statement, in our quality program, we will say, for these risk level of devices, we will test them on incoming inspection and make measurements and keep them, document them, and we will do post-repair, same thing, but in between, we're a run till fail strategy. Run till fail. Now, keep in mind, we can't do run till fail on all of the devices. The regulators will not let us, and that's a good thing. Because there are a lot of us, unfortunately, who would just do everything run till fail. Guess what? The cost of maintaining an inventory of medical devices, when you take that strategy, is 30% higher. What's your benchmark? Let's just say, rule of thumb, 10% of the purchase price of the medical device per year is what you should reserve for maintenance. Now, if you're doing preventative maintenance programs and you're effective with them, you could reduce that by about 30%. Or if you're not, it's going to be that one and more and more. Because you're not catching problems early while they can be easily fixed. You're waiting till failure, and that failure was catastrophic. It happened during clinical use. Oh my gosh. Now our reports to the FDA about potential risk of injury or death go through the roof. Now all the auditors are coming in to look at us and say, what the heck? Okay. You can save the hospital money. We talked about costs as a benchmark for best practices. We talk about reducing patient risk, which is involved here as well. Maintaining a higher uptime, which is all part of this, so that the mission critical medical devices are available when they're needed. Okay, including the ventilators. So we've already talked about this one. This is all about making sure you have a policy statement that follows CMS mandate now that says, especially for critical devices or all of our devices, are going to follow the manufacturer's inspection procedure. Thank God they got off this. You've got to use the same test equipment. How many of you would really like to have a different test instrument for every single brand and model of medical device? That wasn't going to work. We were right in the middle of the recession, if you'll remember, 2011, 2012. Thank God we were all using databases, CMMS systems, and had documented all of this. CMS never asked anyone, by the way, before they made their decision. So it's a little weird. But we've already talked about this. Comprehensive testing. So again, this slide is a little commercial, so I'm not going to talk a lot to it, but I will say one thing. When you're doing ventilator testing, be sure that you're using a certified test lung, not just any old thing. And even my friends at Draeger, for example, the test lung that they're using is not certified. It's not really, I mean, they say, this is what we want you to use, but it's not a certified lung. It doesn't have compliance, resistance, airway resistance, and total capacity specifications. And that's what I mean by a certified test lung. Something its manufacturer stands behind. Who recognizes, aside from the logo on here, who recognizes this test lung? Who does it come from? IMT. IMT. There are some lookalikes that are out there as well. The Mackay what used to be Siemens 190 test lung, which we still sell, for example, we wish was a certified test lung.
It is. It has a 20 and a parabolic resistance of 20.
How do you know that?
Because it said the right of the manufacturer, Siemens. Well, not Mackay, but Siemens.
It does not. When was the service manual you looked at that said that?
Or it was on the 300.
On the 300s.
300s, or maybe 900s. I don't know. And the Servo I, they mentioned.
On the Servo I, okay.
And then the neonate lungs, they also supply as a
Okay, finally. I was the product manager for the Servo 900, as I said, it's an anesthesia system here in the US. And I could not get that information, even after they've never given me that information. And so as a result, we kept that out of our list of certified lungs. So get one of my business cards, please.
Sure, I'll email it to you.
Yes, please. Let me know so I can see it, and then I can adjust. Because that's important. I don't want to close anybody out.
Well, Siemens lung is an industry standard.
Duh. Yeah. It was kind of the predecessor of this one. Okay. So then there's a different version of this one that has an adjustable airway resistance and some adjustable compliance, which is fine. And I think initially when they brought that out, it was a little wonky on the compliance, but it's okay. As long as there's a specification, it's part of your testing system. and it can be traceable because of that. There's a spec. If it doesn't meet its spec, you can go back to the manufacturer. That's the key. Okay. And it can participate in your unbroken chain of traceability. We'll talk about metrology in the next session. But just make sure that you have what you need to carry out the whole inspection procedure when you're doing ventilator testing, because as we've already recognized, we have electrical safety to do. Okay. Among other things that we're looking at.
Sure, I got a question.
Sure.
Your AccuLung and quick lung and the difference between the two.
So the quick lung, this is from a different manufacturer who also makes test lungs for training and test lungs for laboratory testing and an active test lung as well, high end. Too expensive for a hospital biomed department by far. But you, there's always somebody.
No, their AMAR makes some really good stuff.
Yeah.
It's worth the money.
Yes.
$5,000 is all.
I love them, and that's why we went to them and had them do a private label of this one for us. So for us, it's called an AccuLung, and we made them agree to specifications for the lung for Cal and to do a Cal procedure. And that is really the difference between the quick lung and the AccuLung, this metal one. So
AMAR will tell you that the quick lung doesn't require calibration.
that's correct. Because it's
Why
just
would the
training.
biomeds then, why would a biomed then get a quick lung as opposed to an AccuLung?
It's cheap. They don't know that the AccuLung is around. They don't know why. Having a certified, one that's certified as part of your testing system with specification, why that matters. So those are the reasons. A lot of times sometimes it's the purchasing. But there's nothing wrong with the quick lung is fine for what it's intended for, which is training respiratory therapists and others. But when we're talking about testing and making measurements from any medical device, the test load matters. It's part of the testing system. You need traceability of calibration on them. And I'm going to stop right there. If you want to know more, come back for the next session. We will go into that in detail. And it really is important, and it becomes more important from here forward for all of you, more than you can imagine right now. Okay. Again, documentation. We certainly have workflow automations systems. We've just released a new one, a new platform called RaySafe 1 QA for diagnostic X-ray testing. We'll flesh that out and broaden its capability in the next year or two, and then we'll begin to talk about it. But we already have a test automation software suite that really works. It saves you time. It collects the measurements every time, documents them, the pass or fail every time, makes it so that you have a visually guided workflow, so your least experienced person and your most experienced person deliver the same document test result file. So everybody is following the same workflow and procedure. And why is that important? It's audit trail. It's audit trail. And what we have found, what people have told us, and probably not just us, because there's some other competition out there too that are trying to do similar stuff. What I hear is when I use something like this, like our older med tester series, for example, the auditor comes in, sees how I'm doing my testing, and they're good. They don't ask a lot more questions because of the nature of how that workflow is done. So it can help you a lot. Reduces sources of human error in the documentation because of the way that we do things. All of us, the competition as well as us. So please look at them real closely. I don't know what you're using now or if you're using any automation system. Now, by the way, when I say test automation, I'm not talking about hands off. You still have to be there. You still have to be following the workflow. You have to interact with the medical device. There is no closed loop. And even if there were, you still have to make sure that all those settings are correct. The system doesn't have any way to tell at all any part of the system. So we're not talking about walk away. We're talking about improve the pace at which you can get testing done. And there are some other ways of testing for some other medical devices where you can be nearby, not total walk away, but you can be nearby and double your productivity by doing some other testing at the same time. So there are some things like that that you can do. Databases, we talked about those. It seems like there's a new one out every month. There's so many databases, even if they don't call themselves CMMS. There's a module for SAP, there's a module for Oracle, there's all kinds of stuff going out there from lower price point and less functionality to ERP systems that have to be customized, and you better have a programmer, okay, to keep up with it. So this is best practice because we can mine the data. We can pull a report that shows what our testing has resulted in. Now, none of these, to my knowledge right now, actually parse critical measurements that based on the user definition of what those are and does the long-term trend. They all should, but they don't. So they will when we start telling them they have to. Okay. So just think about that. They follow the market, what the market demands. That's what they're doing. All right. Choose a good analyzer. So, all right, so this is real commercial. I warned the product manager when he created this slide set, you can't do this. So you can read it. We show our picture. You think about the tester you're using. By the way, how many knew that the PTS 2000 is no longer supported? Okay, so if you haven't replaced that yet, you better do it quick. Do it soon. I hope you choose us. The other really good ones out there, though, besides ours, are the TSI Certifier FA+. Sometimes there's a few things that are a nuisance to do with it. Okay, and the INT still makes good testers. Still, we private labeled one, and we call it the VT305. So that should tell you something. It was good enough to be included in our gas flow family, right? But we're real competitors. They have a place though, because for a long time they have built ventilator sub-assemblies. They do design work for all kinds of things, mostly around gas flow and ventilators. They're a great company, don't get me wrong. So make sure that you're getting as much for your money as you possibly can. These test instruments are not cheap. Okay, we're talking, yes, sir.
Quick question. If you came up with this, how long are you going to support the VT+?
It already is no longer manufactured as of last month.
How about support?
Support for at least 5 years, that's our guarantee. Once we discontinue, again, this is commercial, but I'm answering a question. Once we discontinue any test instrument, our guarantee is that we will support it for at least 5 years. There are times that we've been caught short though, and critical parts have gone unavailable in the marketplace, anywhere in the marketplace. So believe me, we look at gray market, we look at everything in order to keep our promise to all of you. And if we can't, we're going to try and give you the best path we can to whatever works better. Okay, so if you have VT pluses, you have to look at how old they are. The older they are, the more you ought to think about budgeting and making a move. And these are all available for you to demo, try out. Yeah, cool, sir.
So what's the, so for your VT900, what's the easiest way to find out for the firmware update? Is it just calling this for service, or I mean the tech support?
Tech support should be able to give you that information. If they don't have it at hand, they'll find it for you and get it to you. We are updating firmware because, as I say, we have a really much more sensitive sensor in there now, and we're running into things that were unexpected in real use. So then we're making sure that we get with especially brand and model specific on ventilators. If we figure out that it's something that is normal for the ventilator, but we're not responding to properly, we're too reactive to, then we're gonna find a way to work with that manufacturer. That's part of what we do to make sure you can do your work the best. It's all about the patient. It's all about the patient. If we can't help you keep that patient safe, we sure as hell don't deserve to get paid. Okay? But if we can, then we want you to trust us. And that's why we do a lot of this training. How many of you are aware of the Advantage Training Center? They good? What does it do?
It's an LMS program. You go through it and you have different modules and we'll teach you everything about aspirators to ventilators to
Yes.
risk management, risk assessment.
And you get what out of it?
I don't know, I'm only halfway through, so. Knowledge.
You get a certificate of completion for each and every course that you complete.
Where is this at?
So right on our website, if you go to the Knowledge Center now, because we just changed our website, so you got to hunt for some things. Under Knowledge Center, you have Advantage Training, which takes you to the on-demand